Okay, so this is going to go through the coefficient of determination, r squared, and later we'll see there's a relationship between r squared and r, so there's a relationship between Pearson's correlation coefficient and the coefficient of determination. And the coefficient of determination, or r squared, tells us the degree to which the value of the dependent or response variable can be predicted from the corresponding value of the independent variable or the explanatory variable. It's called the coefficient of determination. What it does is it gives us the percentage variation in the response variable that can be explained by the variation in the explanatory variable. So let's just do an example. I've got a whole bunch of data there. So let's calculate the coefficient of determination for the following amount. So if you do more study, you're probably more likely to get a better test result. So this person here did 0 hours of study and he got a 45% test result. This person got 0 and got 70. He's pretty bright. 160, 190, 270, 280, 295, 390. So there seems to be some sort of positive relationship there. Okay, if we put it into our CAS, go into spreadsheets and call it hours of study. Let's go hours of study and test result. So test result, and we go 0, 45, 0, 70, 1, 60, 1, 90, 2, 70, 2, 80, 295, and 3 at 90. Okay, again, the best way I think to get the R value is to go menu, for statistics, stat calculations, linear regression a plus bx, and your explanatory variable is the number of hours studied, and your response variable is the test result. Alright, and what does that give us? It gives us that r squared is 0.4475. So it's not the best indicator in this case, although it looks like it seems logical that, you know, if you study more you should have a better test. It's not the best predictor. So you get this 44.75% sort of figure that tells us the following. So r squared is 0.4475 if I've put in all the values correctly. Alright, to 2 decimal places that would be 0.44. We look at the one to the right of the last decimal place that we want, so that's a 7, it's above 5, so I have to round up, so 0.45 to 2 decimal places. Okay, now interpret the result. This r squared value is a proportion, but we need to write it as a percentage, so to do that you multiply it by 100. So you go, okay, therefore 45%, because if you multiply this by 100 you get 45. 45% of the variation observed in the response variable can be explained by the variation in the explanatory variable, which is the hours of study spent. Okay. So basically, the coefficient of determination is just a number which tells us how well something varies with respect to something else. So how much can be explained by one other variable. So what is the explanatory variable in this problem? Well, that number of hours studied seem to predict the test result. So that's the explanatory variable. What is the response variable? Response variable is test result. So what would it look like? Visually, always you're going to have the response variable on the y-axis, the vertical, and the explanatory on the horizontal. What is the Pearson's coefficient for this coefficient of determination? Okay, so I'm just going to use the rounded value here, and you'll see that in your spreadsheet it's given to you. R is 0.66. Okay, it's a positive value because as you study more, your test result seems to increase. Okay, you could also, let's just do it in a calculator page. So if I go into Home and Calculator, if you knew that your R squared value is 0.45, then what you can do is take the square root of that R squared value, and that will give you R. So 0.45, okay, that gives me 0.67, which should be close to what my spreadsheet gives me. Yeah, pretty close, isn't it? R here is 0.668, 0.67. Okay. Now, looking here, if you knew that R squared is this number, calculate R, you would do exactly what I did with the calculator. You would do the square root. But then you need to be careful because this is a negative gradient, so your answer should be negative. Your calculator won't do that for you. You need to recognize that if you have a negative relationship, then your R value is going to be negative. So if you do the square root of 0.565, I think it was, square root 0.5625, doesn't really matter what the number is. Alright, that's 0.75. So we go back. That's negative 0.575 because it's going down. And same thing here, if you get an R squared value of 0.36, it's a positive relationship, so you should have a positive value here. So we're just going to quickly go through a summary. R squared is a proportion, so a decimal, that you need to convert to a percentage by multiplying by 100. R squared as a percentage, it tells you the following. The percentage variation in the response variable, that can be explained by the explanatory variable, so how much of it can be explained by the explanatory. You use the following template when answering questions about the coefficient of determination. You have to convert it to a percentage, so if you multiply by 100, the percentage of the variation in the response variable, okay, so whatever it is in the question, you have to write that down, can be explained by the variation in the explanatory variable from the question, whatever that was. Okay, and then you have to be careful. If you're given your R squared value, there's two numbers that satisfy that equation. Say R squared equaled, it can't be 2, but or 4. It can't be 4 because R is going to be between -1 and 1, but just say it was for the moment, right? If you have this equation, R squared equals 4, that basically says what number multiplied by itself twice gives me 4. And the answer is 2 or -2. There's two solutions there. So you have to be really, really careful and take note of the gradient if it's positive or negative, especially in exams and everything. So we've already showed you the CAS stuff, but you really need to be careful if you're trying to find r from just r squared. Just make a note, is it a positive or negative gradient? Should my answer be positive or negative? And that's it.